Bleach is one of the most widely used substances around the world. Not many of us may know how it actually works, so today we're going to learn about how it works, what it does, and some other interesting uses for bleach. So what is bleach? A better question is, what are bleaches? I say that because bleach is a catch-all term for a family of molecules, and bleaches are any substance that removes color from things like fabric, yarn, paper, textiles, etc. And this process is called bleaching. Now, another use can be as a disinfectant, and I think most people use bleach as a disinfectant. And this can destroy things like bacteria and all kinds of other stuff. And we're going to talk about some of this stuff as we move through this video. So what are they made of? Like I said before, bleaches are a family of compounds. Now you got two different types, at least the domestic uses for them. You have chlorinated bleach, and these have chlorine. Then you have non-chlorinated bleach, and these don't have chlorine. Now the main ingredient in chlorinated bleaches is a compound called sodium hypochlorite. In non-chlorinated bleaches, you often find hydrogen peroxide as one of the main ingredients, along with some other stuff involved. This is hydrogen peroxide right here. A lot of us have heard about it and used hydrogen peroxide. And an interesting fact is that ozone is a bleach. Chemically, it does what bleaches do, so it's considered a bleach. So if we go to number 2 here, Clorox, the very popular liquid bleach, has a main ingredient, sodium hypochlorite, like we talked about earlier. Now this ingredient does some specific things we'll talk about in a second, but it's important to know that oxygen and chlorine are the main pieces. Now oxygen is like the main player in this reaction, and chlorine is like a very reliable sidekick. I'm not going to get into the specifics of the reaction, but I'll try my best to explain it as we move on. So I mentioned that chlorine is a necessary part of this compound. And the interesting thing about chlorine is that elemental chlorine, chlorine gas, is actually toxic and corrosive. What we're going to talk about a little bit later is that if you mix Clorox with other cleaning agents, you could release chlorine gas, which you do not want. And this is what chlorine gas looks like right here. So I consider bleach to be something like a double-edged sword. So let's talk about what I mean by that. So first of all, bleaches do a whole lot of things, and what I'm going to explain is a very, very bare bones definition. So bleaches will steal electrons and break chemical bonds. Now this process is much more complicated than I'm letting on, but let's do a little review. So you got your atom, protons, neutrons, then you have these electrons. These electrons are what connect with other electrons to form a bond. Let's consider water. The connection between hydrogen and oxygen is formed because the electron cloud of hydrogen and oxygen kind of come into each other's area and they connect. So that's the bond that forms. And bleaches almost break that bond in a more complicated way than I'm letting on, but they are called oxidizing agents. They oxidize compounds. And this means you can add an oxygen and remove a hydrogen, or just remove an electron in general. Like I said, I'm not going to get into specifics, but that's the bare bones definition. So let's consider what bleach does as far as color is concerned. So we're going to go over here to this molecule, brilliant blue. Brilliant blue is what it says, is a very blue compound. And I've described earlier in my other videos how color works, but we're going to do a quick review. There are certain molecules that when light hits them in certain places, these molecules absorb the color spectrum and then reflect the color that we see. So in this case, brilliant blue reflects blue and absorbs everything else. Now, these molecules have these sections called chromophores. And they're all a little different. In my research, I couldn't find the specifics, but I believe the chromophore section will be somewhere in here. If anyone knows more about this, please comment. But it's essentially an area where all this action takes place. And bleaches work by disrupting these chromophores and messing with the structure so that it alters the way these molecules absorb and reflect light. And then we know that bleaches are antibacterial. What they do is when they oxidize things like the outer layers of bacteria, they'll break down the fats and proteins and destroy the structure as well as the DNA and things like that. And it goes the same for hair. It'll break down some of those proteins, destroy some of the color, which is why bleaching is not very good for hair, because it can destroy the structure of the hair itself. Okay, so let's move on and talk about the other side of bleach. Okay, so this I've titled quote unquote the bad. So bleach has a molecule called sodium hydroxide. Now, sodium hydroxide is a tissue irritant. But what does that mean? What happens is that when sodium hydroxide comes in contact with skin, it breaks down the structure of the fat that our skin is made of. And this process is called saponification. What's interesting is that this same chemistry is what happens when you're trying to make soap. Because when you're trying to make soap, you want to break down the fats and convert them into products that you can create soap with. It's a very, very bare bones explanation. But if you get bleach on your skin, especially concentrated bleach, it can result in pretty severe chemical burns, especially if you get on your skin, your eyes, really any part of your body. You don't want to get it on there because it's not going to be fun. So earlier I mentioned that you don't want to mix bleach with other cleaners because it could release things like chlorine gas. Let's talk about that a little bit. So if you mix toilet cleaner, most toilet cleaners with bleach, you could release chlorine gas. Now, why is that bad? Chlorine gas will burn your lungs, skin, and eyes. It is not something you want to mess around with. What's interesting is it is a gas. Most people would think a liquid would burn you, but in this case, gases are very toxic and can destroy living tissue very easily. And if you mix an ammonia-based cleaner with bleach, you'll create this molecule called chloramine gas. Now, chloramine gas can irritate the eyes, nose, throat, the airway of the human body. It's not something you want to smell. It's also very flammable. And this is actually what contributes to the smell of pools when they've been chlorinated. There's controversy surrounding it because this gas is not good for you, but it's a whole nother video. And then if you mix bleach with vinegar, you'll release chlorine gas. And we talked about that earlier, how it burns your lungs, skin, and eyes. In general, the whole idea is that you do not want to mix bleach with anything unless it's like water to dilute it, because it can result in some pretty nasty chemicals being produced that you do not want to breathe in or touch at all. So let's talk about non-chlorine bleaches. So non-chlorine or color-safe bleaches, a lot of them have hydrogen peroxide, and these release oxygen to clean without destroying color. Again, this is a very bare bones explanation. I actually don't know a whole lot about this, but I just wanted to include it because I thought it was really interesting. But it's not as harsh as a sodium hypochlorite bleach, which is why it's used and why it's color safe. Now, the issue with bleaches like this is that you don't want to mix it with an acid like vinegar because you will create peracetic acid, which will be a liquid, but it rapidly converts into a vapor, which can be corrosive and toxic, similar to chlorine gas. Again, this is not my forte, so if anyone has any extra thoughts, please put them in the comments because I'd love to learn more. And then bleach can be used for stagnant water to get rid of mosquitoes. It can be used to keep cut flowers fresh by destroying the bacteria in the water. Just a little bit of bleach and some water can help, and it can help keep Christmas trees fresh by that same principle. So let's go back and review the video and the summary and just go over what we learned today. So we learned that bleaches were a family of molecules that not only remove color in a process called bleaching, but they also can be used as disinfectants. We learned that the domestic uses for bleach can be chlorinated or non-chlorinated. We learned that Clorox has a compound called sodium hypochlorite that does the job we wanted to do. One thing I didn't mention is that halazone right here is a chlorine releasing compound like Clorox that's used to purify drinking water. Forgot to mention that as we went on. And then we talked about how bleach will steal electrons and break chemical bonds. Obviously, this is a very bare bones explanation. It performs this oxidation reaction that can remove color from a substance by attacking those chromophores. And it also can destroy bacteria by that same oxidizing process. And then we spoke about how bleach has sodium hydroxide that can be a nasty tissue irritant. It can break down the fats in our skin, resulting in chemical burns. And then we spoke about how you cannot mix bleach with any other cleaners because you could release things like chlorine gas or chloramine gas. Either one you don't want to breathe in or get on you. And then we learned about non-chlorine bleaches, these color-safe compounds that can clean without destroying color. And we don't mix them with things like vinegar or acids because it can create some nasty chemicals. Then we mentioned how bleach can be used for stagnant water, for cut flowers, and Christmas trees. So that's all I got. I learned a lot from this video. I actually had to go back to the drawing board yesterday to tweak some things. I hope you guys learned a lot. And as always, thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.